Hello guys, welcome back again to another video of your class 12 mathematics. In today's video, we're going to study about nothing more than your application of derivative, your application of derivative. So today's topic is about your tangents and normals. So basically we're going to start with your exercise 6.3. So let me just highlight you with the formula. So according to tangents and normals, it's given that the equation of a straight line passing through a given point x naught y naught having finite slope m is given by this one, y minus y naught is equal to mx minus x naught. Okay, so from here, if you have to find the value for m, so m will be nothing more than your y minus y naught divided by your x minus x naught. That is nothing more than your slope. So which is defined to be nothing more than your slope. So it's given that then the slope of tangent. Remember, a tangent is always a point passing through the curve. This one is nothing more than your curve. So a tangent is given to be this one. So it's given by this. So remember that. Also remember that your m is nothing more than your dy by dx. Okay, so which is nothing more than your slope of the tangent. So over here is given that so that the equation of the tangent at x naught y naught to the curve y is equal to f of x is given by y minus y naught is equal to f dash x naught x minus x naught, or in short the equation of the tangent is also can be written as, let me just write blue line that with red mark, it will be y minus y naught. Okay, it's or y minus y naught is equal to m x minus x naught. And what is m? M is nothing more than your slope of your tangent. Remember, your slope of your tangent is nothing more than your m. So that was all about your slope of the tangent. In a similar manner, is given that also since the normal is perpendicular to the tangent. So you remember that normal of a line is always perpendicular to the tangent. So the slope of the normal of the curve is y is equal to f of x at x naught y naught is nothing more than minus y. So your in short, if m is the slope of your tangent, your slope of the tangent, then in short your slope of the normal will be nothing more than minus 1 by m. That is nothing more than your slope of the normal. Slope of the normal. Okay, slope of the normal. So the slope formula is that, or I can say nothing more than y minus y naught is equal to minus 1 by m x minus x naught. Okay, so let me just try to give you in a brief manner. So do remember that as a note, always remember that your slope of the tangent, is nothing more than your m, or I can say nothing more than your dy by dx, or I can say your sorry, not this one, or I can say nothing more than your f dash x. That's your slope of the tangent. And similarly your slope of the normal, now in place of tangent is normal, which will be nothing more than minus 1 by m, or I can say minus 1 by dy by dx, or I can say minus 1 by f dash x. Okay, so these are the, I can say, the first point and the second. And also do remember that your equation of the straight line is nothing more than y is equal to your mx plus c. That's nothing more than your equation of a straight line. And number 4, I can say that if, that's actually from class 11, okay, if two lines are parallel, it means their slopes will be equal. So m1 will be equal to your m2. Remember, if two lines are parallel, that means your m1 will be equal to your m2. And in a similar manner, if two lines are perpendicular, so it means your product of the slopes, that means your m1 dot your m2, sorry for mistake, the product of slope, your m1 dot your m2 would be nothing more than your minus 1. So to remember this one also. So point number 3, point number 4, and point number 5, also remember that when question of straight line is nothing more than y is equal to your mx plus c. And if the two lines are parallel, it will be, the slopes will be equal. And if two lines are perpendicular, their product of the slopes will be equal to your minus 1. All right, so these are the basic ones. So let us try to deal with some of your questions. So let me start with your exercise 6.3, your question number 1. You can see your textbook is given that nothing more than find the slope of the tangent. So the curve is given that the curve is given to be y is equal to 3x to the power 4 minus 4x, and is given at x is equal to 4. So it's very easy. First of all, differentiate dy by dx, so that will be nothing more than 12 x cubed minus 4. Then the slope of the tangent at x is equal to 4, which will be nothing more than, I can say, m is equal to your dy by dx. Remember that the point is given to be x is equal to 4, so that will be 12 into 4 cubed minus 4, so which is 12 into 64 minus 4, so that's nothing more than your 764. So that's your answer for your question number 1. Okay, in a similar manner, let me try to do another question. Yeah, let me just try to do question number 3. So if I happen to do question number 3 is given that find the slope of the tangent to the curve. Okay, again the curve is given. The curve is given to be y is equal to x cubed minus x plus 1. So it's given that at the points whose x coordinate is 2. Remember the value for x coordinate is nothing more than 2. So I can say that at x is equal to 2. So same thing, find your dy by dx. So which would be nothing more than 3x squared minus x. Then your slope of the tangent. It's given to be at the point whose coordinate is whose x coordinate is at 2. So I can say that your m is equal to your dy by dx at x is equal to 2. So that will be nothing more than 3 into 2 square minus 2. So the answer would be, I can surely make this one to be, I think I have done one mistake, and that mistake is seen over here. That should be actually nothing more than your 1. So if that's 1, that means over here also it's a mistake, so that should be nothing more than your 1. So I will get here 12 minus 1, nothing more than your 11. So that is how to be done over there in question number 3. Again, let me just jump to the next question. Yeah, for the next question, let me just try to focus over there, nothing more than your question number 5. Over there in question number 5, the question is a little bit different because here the curves are nothing more than x is equal to a cos cube theta and y is equal to a sine cube theta, and it's given that at theta is equal to pi by 4. To remember that whenever we're finding any slope of the tangent or slope of the normal, basically we have to find this one, nothing more than your dy by dx. Okay, but over here your x is different term and even your y is a different term, so what I have to do, I have to differentiate both of them in different manner, and the parameter over here is nothing but theta. So what shall I do is that I'll give this one equation 1 and this one to be your equation number 2. So differentiating equation 1 with respect to theta, I'll get here dx by d theta. If I differentiate that, I'll get nothing more than a into 3. I'll get here cos squared theta and then minus sine theta. So the answer would be nothing more than 3a, sorry, minus 3a sine theta, and I can say cos squared theta. Similarly, differentiating equation 2 with respect to theta again. With respect to theta, I'll get here nothing more than your dy by d theta. If you're wondering how did I got this one, let me just try to focus this one over here. Okay, remember a is constant, and I can say that the sine cube theta, I can make this one to be nothing more than your sine theta the whole thing cube, right? But this is not theta, so I have to consider this one to be theta. So if I consider this one theta, so theta cube will be how much? That will be nothing more than your 3 and then sine square theta. But there's no theta, I have differentiate, so it will be nothing more than your cos theta again. So in short, I'll get the answer 3a cos theta and then sine square theta. And still now, if you're not what do you call ready enough, or you don't know how did I got from here to here, I want you to go through chapter 5 once again, okay? Because without chapter 5 you can't do chapter 6, or I would say not even the calculus also, so just focus over there. So I can say that here your dy by dx would be nothing more than your dy by d theta divided by dx by d theta. So which one I'll get here? Nothing more than your 3a cos theta and then your sine square theta divided by minus 3a sine theta and then sine theta and then your cos square theta. So what can I cancel? I can cancel cos with squares, this and 3a cancel. So I'll get the answer nothing more than minus tan theta. Remember that I got your dy by dx to be your minus tan theta. But the question says that I have to find the slope of the normal. So I can say that here the slope of the normal, the slope of the normal at the point is given to be theta is equal to pi by 4 is equal to nothing more than minus 1 by m. But your m happens to be minus 1 by your dy by dx, and the value for theta is given to be your pi by 4, so which is minus 1 divided by if I can go back, I got your dy by dx to be minus tan theta, so I can make this one to be minus 10, and the value for theta is given to be pi by 4, so pi by 4 I can cancel your minus and minus, so I get a 1. 10 pi by 4 is nothing more than 1, so it is equal to 1. So the slope of normal is nothing more than your 1, and hence that's your answer. I hope you are clear with it. Okay, let me again jump to your next question. Okay, over to your next question. Let me just jump to your question number 8. Over there in question number 8 is given, find a point on the curve y. Okay, the given curve. So the given curve is nothing more than y is equal to your x minus 2 the whole thing square. Okay, no matter what you got the curve, always find your dy by dx directly. So if I got dy by dx, I'll get this answer to be your 2x minus 2. Then focus with the question again. It's given that at which the tangent is parallel to the chord. Remember, it's parallel, that means their slopes will be equal. It's given parallel to the chord joining the points. Okay, I can say that again, or I okay, let me just grab this one and then make it some more interesting thing over here. So I got dy by dx, so I can say that your slope of the tangent. Remember, the curve and the tangent is always proportional, so tangent is nothing more than m. I can make it m1, so I'll get here nothing more than your dy by dx, so which is nothing more than 2x minus 2. I'll just keep like this. Okay, so again, it's given that the chord of the points nothing more than the points given to be 2 comma 0 and 4 comma 4 is parallel to the curve, right? So I can say that your slope of the chord, your slope of the chord, like you make it to m2. According to the formula, is nothing more than your y2 minus y1 divided by x2 minus your x2, and then it will be minus your x1. So your y2 happens to be 4, so that will be 4 minus 0 divided by 4 minus 2. So in short, your m2, I got it to be nothing more than your 2. So next line, I can just simply go over there and then say that as they are parallel, which I've already mentioned, as they are parallel, so I can say your m1 is equal to your m2 because their slopes will equal. So m1, let me just go back and see, m1 is equal to x minus 2. So I got it 2, and I got x minus 2, and I got this one to be 2. So I can cancel your 2 and 2, so x minus 2 is equal to 1, so x is nothing more than your 3. So I got x because I have to find the point of the curve, so let me make this one to be equation number 1. So next step, I can say that putting x is equal to 3 in equation 1, we get, so if I put x is equal to 3 in equation 1, I'll get here y is equal to your x minus 2 the whole thing square, so that's nothing more than 3 minus 2 the whole thing square, which is your 1 square, nothing more than 1. So I can see the required point is x comma y, and that is nothing more than your 3 comma 1, and that's your answer. All right, so let me again go to your next question. I'll just simply jump to your next question. Let me just try to do a little bit interesting one. Question number 14. For question number 14, focus carefully. It is given that find the equation of the tangent and normal. Remember that I have to find the equation of both the tangent and the normal. So I'll do 14.1 is given that the given curve is given to be y is equal to x to the power 4 minus 6x cubed plus 13x squared minus 10x plus 5, and the point is given to be nothing more than 0 comma 5. So whenever you got y, I already said it, always find your dy by dx. So if you find dy dx, I got a 4x cubed minus 18x squared plus your 26x minus 10. All right, so if you got over here, what you can do is that because I defined both the equation of tangent and normal, so I can say that your slope of the tangent, remember the point is given to be at 0 comma 5. Okay, and one more thing I totally forgot to tell you is that remember, whenever we have to find the equation of the tangent or equation of the normal, always a point will be given like this. Okay, if you didn't got the point, you have to get the point, and this point is called nothing more than your critical point. So remember, whenever you're doing any equation of the tangent or equation normal, you always have to get your critical point. So it's given that your slope of the tangent at 0 comma 5 is, I will say, your m is equal to your dy by dx. So I got dy by dx as nothing more than your 0 comma 5. So if I put a value, I'll get here, because the value for x happens to be 0, so it'll be 4 into 0 cube minus 18 into 0 square plus 26 into 0 minus 10. So in short, I got your m to be nothing more than minus 10. And similarly, slope of the normal slope of the normal at something 0 comma 5 is slope of the normal formula is nothing more than minus 1 by m, so which would be nothing more than minus 1 by minus 10, so it is nothing more than 1 by 10. Okay, and one more thing, keep focus on this one. Remember, I got minus 1 by m to be nothing more than 1 by 10. Okay, why I'm saying so, you will know on your next page. So let me just try to do it for the next page. So I can say that hence the equation of the tangent at the point is given to be 0 comma 5 with slope I got nothing more than your minus 10 is, first of all, write on the formula. So y minus y naught is equal to m x minus x naught. So if I do that, I'll get a y minus 5, because the value for y naught, remember, this is always your x naught and your y naught. Okay, so once you got over there, which will be m is minus 10, and then your x minus 0, so which is y minus 5 is equal to minus 10x. So I can say that 10x plus y minus 5 is equal to 0. And one more thing, always try to keep the value for x to be positive all the time whenever you're finding the equation of tangent normal. In the answer, sometimes the value for x happens to be in minus also, but you can take always to be in positive so that you will know what you're trying to do. Okay, so let me just find again, and the equation of the normal at something 0 comma 5 with slope I got slope to be 1 by 10, remember. Okay, so it's nothing more than y minus y naught is equal to minus 1 by m x minus x naught. So it will be y minus 5 is equal to 1 by 10 x minus 0. Okay, remember over here I got here 1 minus minus 1 by m, but I didn't write here minus 1 by 10. Okay, why? Let me just go back again. Focus over here. See, minus 1 by m, I call it to be 1 by 10. In the exam, most of you are gonna do mistake over here also, so check once again and then always try to do that. Okay, so I'll get this one to be, let me just try to over here, I'll get this one to be your 10y minus your 50 is equal to x, so it will be x minus 10y plus 50 is equal to 0. See, I always took the value for x to be in positive, so that is the answer I got. All right, so that was nothing more than your question number 14. Okay, So again, let me just jump to your next question. Your next question happens to be nothing more than your question number 15. And question number 15, again, the question is different. Okay, it's given that same thing, the curve. So the given curve is nothing more than y is equal to your x square minus 2x plus 7. So I'll get here dy by dx, which would be nothing more than your 2x minus 2. Okay, now after that, read the question. It's given that this curve is given and which is parallel to the line. So it's given parallel to the line and perpendicular to the line. If you focus over there in the equation, there is no critical point. So as I said, whenever you have to find equation of anything, you just have to get the critical point first. Okay, so give this one to be equation number 1. So I can say this one to be your slope of the tangent. Let me just make this one to be your m1 is equal to your 2x minus 2. So number A is given that the given line. So the given line is nothing more than is given to be your 2x minus y plus 9 is equal to 0. So I can make this one to be x is equal to y. Okay, sorry, not x. I did some mistake over here. So I can make this one. I need y actually. Okay, y is equal to, it will be nothing more than 2x plus 9. So which is of the form, nothing more than y is equal to your m2x plus c. And those who are wondering what is that, what is this one, is nothing more, this is nothing more than your equation of straight line. Okay, so over here I can make this one to be here your m2 is nothing more than your 2 and your c happens to be your 9. So let me just go to your next page again. So as the given curve, I will say, as a given curve is parallel to the given line, so I can say the slopes are equal. So there will be m1 is equal to your m2. Let me just go back again. Your m1 I got it to be 2x minus 2. So there will be 2x minus 2. Your m2 I got it to be nothing more than 2 again. So that will be 2x is equal to 4. So x is equal to 2. So I can say putting x is equal to 2 in equation 1. So equation 1 happens to be y is equal to that. So y is equal to nothing more than, I'll get this one to be I got the equation to be 2 square minus 2 into 2 plus 7. So y is nothing more than your 7. So in short, so therefore the critical point is nothing more than your x comma y, so which is, that is 2 comma 7. So again, let me go to your next page. So I can say hence the equation of the tangent, because I define equation of tangent, and the point I got to be 2 comma 7 with slope. Now let me come back to your slope. If you can look over here, your slope of your tangent is nothing more than m1, and I got 2x minus 2. But over here, I got m1 is equal to your m2. So your slope will be nothing more than 2. Okay, this is how we're gonna do without calculating. So with slope nothing more than 2 is y minus y naught is equal to your m1 x minus x naught. So y minus 7 is equal to 2 x minus 2. So that will be y minus 7 is equal to your 2x minus 4. So that is 2x minus y minus 4 plus 7 is equal to 0. So 2x minus y plus 3 is equal to 0. Now if you can look at the formula that I have written down over here, the slope, I make it into m1. Okay, why? Because you can just see on the previous one, your slope of the tangent is nothing more than your m1. That's why that's nothing more than your m1. So this is what I got the equation. So that's your part A. Let me just try to do your part B again. Your part B, again, the given line is, I got the given line to be nothing more than 5y minus 15x is equal to 13. So it will be y is equal to 3x plus 13 by 5. So which is of the form y is equal to your, I'll make this one to be m3x plus c. So here M3 I got it to be 3, and your your C, I got it to be your 13 by 5. So as the curve is now perpendicular to the line, so whenever it's perpendicular, that means the slopes will be, product of the slopes will be nothing more than -1. So I'll get here, M1 I got it to be 2x minus 2 into 3 is equal to 1 minus 1, so which is 6x, again, sorry for the mistake, which is nothing more than your, 6x minus 6 is equal to -1. So your x is equal to, let me just see whether I did any mistake or not. Nope, there's no mistake. So 6 become plus, so it will be 5 by 6. So putting x is equal to 5 by 6 in nothing more than your equation number 1. So I'll get here y is equal to, sorry, that's not 2, it's nothing more than y is equal to your x square minus 2x plus 7, so that will be your 5 by 6, the whole thing square, minus 2 into 5 by 6 plus 7, so that will be a 25 by 36 minus 10 by 6 plus 7. So if you simplify, you should be getting the answer nothing more than 217 divided by your 36. Okay, so that is what I got. So that the critical point is, nothing more than 5 by 6 comma 217 divided by 36. All right, so hence equation of tangent at point 5 by 6 comma 217 by 36 with slope. Now let me go back again. If you can look over here, I got m1 dot m3 is equal to -1. So in short, your slope m1 will be nothing more than, I'll just do it again, -1 by m3. So that is -1 by 3. So the slope over here will be nothing more than -1 by 3. So slope is nothing more than -1 by 3. So I got here y minus y naught is equal to m1 and then x minus x naught. So that will be y minus 217 by 36 is equal to -1 by 3, x minus 5 by 6. So I'll get here 36y minus 217 divided by 36 is equal to minus, that will be 6x minus 5 divided by 18. So if I cancel, 18 was 18 and 18 to the 36. So that will be 36y minus 217 is equal to minus 12x plus 10. So 12x minus, plus 36y minus 217 minus 10 is equal to 0. So that will get the answer 12x plus 36y minus 227 is equal to 0. So that's your required equation. Again, same thing, you can pause the video anytime, go back. You can, if you're going to watch it slowly also, you can watch it, but try to get the answer. Okay, so this is how to be done, and I hope you got it till now, that whenever you're going to find equation of the tangent or equation of the normal, always remember that we're going to find the critical point. Okay, without the critical point, it's a little bit difficult to find it. So again, some every questions are similar. So let me just try to do a question which is a little bit unsimilar, like your question number 23. Let's see. Your question number 23 is given that prove that the curves x is equal to y square and xy is equal to k cuts at right angle. Remember, whenever right angle comes, the first thing that comes in your mind is nothing more than your 90 degree, and in from 90 degree it means it's nothing more than perpendicular, and whenever perpendicular is there, it means the product of their two slopes is nothing more than equal to your -1. So don't forget that. Okay, so I can say that here the given curves are, here the given curves are, the first one is given to be your x is equal to your y square, and next one is given to be xy is equal to k. So let me make this one equation number 1. So I'll get this one to be your y into y square is equal to k. Let me make this one to be equation number 2, okay? So it extends from 1. So I'll get here y cube is equal to k, or in short, y is equal to k 1 by 3. So if I put the value of y over here, so x would be nothing more than k 2 by 3. So why I'm finding these two is because look at the question again. The question didn't mention anything about the critical point, and I need the critical point. So therefore, the critical point over here is nothing more than k 2 by 3 and k 1 by 3. Alright, now because I've given two curves, so it means two slopes will be there for equation 1 different and equation 2 also different. So let me say what I'm going to do over here is differentiating equation 1 with respect to x. So if you do that, I'll go y is equal to, or 1 is equal to 2y dy by dx. In short here, dy by dx is nothing more than 1 by 2y. So that is slope. The first slope will be your m1 is equal to, I got 1 by 2y. Again, differentiating equation 2 with respect to x. So in over equation number 2, if you can look over here, I got xy, so that means nothing is there between them. If nothing is there between them, I have used the product rule, so that means that will be nothing more than x dy by dx plus y is equal to k is constant, so it will be 0. So your dy by dx would be nothing more than minus y by x. So slope, that is slope, I got this one to be your m2, so that is your minus y by x. Okay, now the two curves meet each other at 90 degrees. So what I will do over here, next line is, I can say that since the two curves meet each other at 90 degree or right angle, so that is, I can say that m1 dot your m2 is equal to minus 1. So m1 is 1 by 2y and m2 is minus y by x. So 1 by 2y into minus y by x is equal to minus 1. I can say y and y, minus and minus. 1 by 2x is equal to 1. So in short, I can say 2x is equal to 1. But the critical point, the point was nothing more than k 2 by 3 and k 1 by 3. And if you can look at the answer, I need the answer to be your 8k square is equal to 1. So it will be 2k 2 by 3 is equal to 1. So if you can look at the answer, okay, let me just highlight the answer. The answer I have to get is nothing more than your 8k square is equal to 1. So if you can just compare this with that, what I don't need is that I have, instead of 2, I need 8. And instead of k2 by 3, I need only k2. So I have to remove that 3. So in order to remove that 3, what I have to do is that I have to cubing. I have to cube on both sides, okay? So cubing on both sides. So if I cube on both sides, I'll get here 2k 2 by 3, the whole thing cube, is equal to 1 cube. So 2 cube is nothing more than 8, and 3 and 3 will cancel, that will be k square, and 1 cube is 1. So hence proof. So that is how question 23 is to be done. Alright, so you can check slowly and then try to steadily.